Okay. Hello. Oh, I forgot in the morning class to talk about the P3.1 deliverable. I've been getting a lot of messages about that. So while I get ready to share my screen, people were worried that if their group mates hadn't posted anything, will that affect their grade? No, I can't punish you for what other people did not do. So that will not affect your grade. I guess so. I'd like your experience. This was a kind of a test run, right? This was the first time we tried it, and I want to do something like it or similar, depending on how it went. So, what was your basic experience with this? I know it was a little rushed. Other than that, what do you think?
Honestly, I loved having the reply. I think Alik's here. The stuff he said was really good.
Okay, good.
But like we had somebody who didn't post at all.
Yeah.
So like we had that experience as well. In the past, like I've had teachers who, and it's sort of like babying us, but it works to like pressure people into like you post first, then the reply opens up for another 24 hours so that there's like no stress. Cause I kept checking last night to see if she was going to post last minute.
Yeah.
And then Alik and I would have to come up with our replies like in the last like 20 minutes before midnight, sort of a thing.
Right. Yeah. So so a little more structure in terms of you must post by this day. One of the reasons that I didn't do it that way this time is because I was a little late getting that online. So, you know, I knew people didn't have that much headway. However, everybody should be expecting it for P4. The other thing I'm going to do to take care of the deadline stuff is it doesn't have to be before the code is in. So it'll be the day that you send code to me, the day that you submit the P4, also put a copy of it on the discussion. And then the discussion can happen after that stressful deadline for everybody. Does that seem reasonable?
Yeah.
Basically, what you're going to do is give them advice on how good or bad, or you know, some kind of advice for their code for the next deliverable is how that works out. Okay. Yeah, Carly, you were one of the lucky ones then to get actual someone posting and giving you feedback, and I'm hoping you gave good feedback to Alik then also.
Yeah, that's what I liked about having it before it was due, because before I turn it in again tonight, you know, for the real 40-point grade, I'm going to go back with what Alik said and check what he said and listen to him. So
okay, good. Yeah, it's all about improving the product, right? You kind of have to put your ego aside, right? So when some people write things, they get upset when people want to edit it, but you have to understand it's about improving the product. So it sounds like you have that mindset, which is good. Okay, I've got a lot of other stuff open because I just came from a meeting. So let me get myself set up for where we are now here. I think that's right. Okay, and we have, all I'm doing now is the file IO running through the code. And I have the 2 slides in the notes that are online that I think I talked through. I don't need to talk through them here in the lecture because we actually, all they are the snippets from the code. So file IO for this course is very simplistic. How many of you guys had to do file IO in CS225, those of you that took that class? I can't remember what Professor Behe requires there. How about EGR 115?
we pulled like Excel files.
Okay.
Is that, yeah, sort of.
Yeah, okay. So, and you made Excel files, okay. And my suspicion is that MATLAB made it really smooth and easy for you to work with Excel. And by the way, with Java, you can work with Excel too. I believe you have to import some special purpose classes, but I have had students do that in the past. That counts as your file IO if you need to use Excel files in your project. All right, so the file IO stuff that we're doing here is very simplistic. Text only is all that's required. If you want to do something different, let me know for your project. Just showing an image is not file IO per se. You need to have the ability to read and to write. And it's pretty straightforward, actually, just to do the text-based. So here's one called write data, and it's this simple. You have, here they're creating a brand new file, scores.txt, and it's, you create a file object. Now, there's two things happening here. One is the physical file in the hard drive or in the RAM, right? That's the physical file that's out there in memory. But this file object that Java is creating is really, think of it more as a file manager. It's the thing that's interfacing between the Java virtual machine and that external memory space where the file resides. So when we say Java IO file, file equals new, well, that tells you right there, it's an object, right? Equals new Java IO file, and then you name the file that you want. Since you said new, you're creating a new object that does not necessarily mean, we'll see in a minute, that does not necessarily mean you're creating a new file, you're creating a new object to deal with that file. And then you have to, just like you did with, remember you needed a scanner to bring in, data in, and you needed to create a, you needed to use the system.out to get data out. You need to create something that will actually send that data stream out to the file. So that's what this print writer is about. And there are different forms that you can create if you look up on the Oracle help pages. But print writer is sufficient for the course. And when you create that thing, that print writer object, you tell it, where is it writing to? Remember, whenever you created the scanner, you had to say, where are you getting your data from? System.out defaults to the console. The print writer could go to the console or could go to a file, and you're saying go to the file. Now, it's unfortunately, I mean, they named it. They named their file object file. So that's the name. That's not the thing. That's the name of the object. And then all they do is print writer acts just like the system.out print object does. So you get print line, the same things we've been using to output to console. And all they do is they print out John T. Smith and a number, Eric K. Jones and a number. Notice what they're doing is it's a single string, like John T. Smith is one string. And if you remember when you did the system.out.println type thing for console output, it took everything that you put in the argument and it converted it to a string and then it pushed it out to the console. And that's what's happening here. So even though you said output.println 10, it's not printing that out as a integer, it's printing it out as a string. Yes, you can do formatted output. We do not need to worry about that for the course. When you're done, remember the name of that writer was output, you close it. So this output.close is a method that closes this resource. In good programming practices, anytime you open a resource, you should close the resource. 30 years ago, it was critical that you did that. Nowadays, the operating systems and the Java virtual machine will clean up your dirty laundry if you leave stuff open, but it's still good defensive programming to explicitly close these things. It always comes down to robustness and security. If you leave a resource open, it's like leaving your door unlocked, right? Somebody else could walk through there. So some actor who has bad intent could try to glom into your executable and try to use that open resource to get in. Ironically, in terms of robustness, it's the opposite is true. If somebody is unauthorized and you still have a resource open, a lot of times that resource is locked. Have you ever tried to delete a file and it says, I can't delete a file because it's open in another application? That other application has the file locked until you close it. I've had a couple of really stubborn instances of that where I was trying to delete a file and it said, oh, it's open in another application. Oh yeah, I forgot I was editing or something. So I closed it out And it's still, the system still believed that I had that file open, and I would have to really backtrack my steps and then come back in order to convince the operating system that no, I'm really not using this file anymore. So anyway, close your resources. Notice how simple this is when you create this file. Now, if I go to my folder, there we are. Get rid of these things. So right now I have read data, write data. So this is how you write the data, and then you can also read the data. Now the difference between writing the data and reading the data, when I wrote the data, or when this person who wrote this program wrote the data, they can do this as a string. Unfortunately, when you read John T. Smith, if you read it like a normal scanner input, every time you see white space, that's one hunk of data that comes in, that's one token. So in order to read it, you actually have to read John, and then you have to read T, and then you have to read Smith, and then you have to read the 10, and they all come in as strings. So just like they all got printed out as strings, they all come in as strings. Everything that comes in from console or file, its default type is a string. And if you want it to be something other than a string, you have to explicitly tell the system to do it differently. That's why, remember when you did console input and it was next int or next double? What you were telling it was, yeah, bring it in. I know it's a string, but convert it to an integer, convert it to a double. And it's the same thing here. So if we see read data, it's not quite as easy. You say, oh, first name, input next. And again, next comes in as a string. So just give me the next token. I know it's a string, but I'm going to assign it to a string, so we're good. Input next. What's the next? It's the next until I see white space again. Input next. And then finally, wait, we're getting that number, so it's input next int. So bring it in, convert it to an integer, and I'm going to assign it to an integer. What's this about? Well, input has next. Well, every file has an end of file marker. And normally we don't worry about it at all. I believe in C, you guys, if there's anyone who took the C class, you did have to worry about that. The end of file marker is saying, hey, there's more stuff, you know, when you come to the end of that, then the system knows there's no more data in that file. And so basically what that is asking is input has next. In other words, have I seen the end of file marker yet? As long as it has something more to print, then bring it in and print it out. And then again, close. So same trick, Java file, right? New file, scores.txt. Now it's not a new file on the hard drive, it's a new object to handle that specific file on the hard drive. And then, because this is input, we create a scanner and we tell the scanner, remember before it was system.in, that's where you got the input for the scanner. Now we're saying, no, we want you to scan the file object. It's pretty, I mean, you know, this is all pretty much by rote. You know, the level of complexity that I'm asking you guys to do with your file IO is pretty low. So this is about as sophisticated as it needs to be. Having said that, notice when you're reading these in, you do have to pay attention to the data types, which means it treats the next string for an integer. It will not run through. It will not run through until it finds an integer. It's whatever's next. It better be able to be turned into an integer or we'll get trouble. And I'll show you an example of that. So when you're bringing things in, you do have to worry about data types, which means that before you write your write piece of, the class that writes and the class that reads, or the method that writes and the methods that reads, you really should sit down and plan. You notice I keep saying that throughout this whole class. Just like with your GUI, you should lay it out, draw out your GUI before you start trying to code your GUI. Same thing with your files. Just lay out a sketch of, okay, what is this file what does the data look like in terms of its content, so I can figure out, okay, I'm going to print, in this case, I'm going to print a string, string, string number. So I need to read in a string, string, string number. And then you want to make sure that that's how the file looks. So plan ahead. Because if you write the code to write to the file on Tuesday, and then you write the code to read from the file on Wednesday, the odds that you actually matched up if you didn't plan ahead are pretty low. Okay, so I'm gonna do first read data. And it won't work. Why won't it work? Oh no, I can't find file not found exception, right? I'm looking for scores.txt and I cannot find the file. Well, why can it not find the file? Because if we look in the directory, the real question is, where is it looking? Where is it looking for that file? It's looking for that file right here. Wherever you're running the code from, the default is to look in that directory. So if you're going to look for something, you look in that directory. Unless you tell the computer to do something different. It is common to have a subdirectory for your data, or here you see there's a subdirectory for the image. And if I look at my, where is it? Test file class. Test file class, they actually say image.usgif. That's the file they use in that particular example, meaning, hey, starting from where you are, go to the image folder, and then inside the image folder will be us.gif. But here in the file that we're actually working with now, it didn't say anything about any other folder. It said, hey, scores.txt, meaning it should be in the folder that we're in right now. Eclipse manages this for you. So that's good news and bad news. The good news is you don't have to worry about it. The bad news is sometimes Eclipse loses the file, and then since it puts it in a location that it doesn't always tell you about, sometimes you have to do a little detective work to figure out what the heck Eclipse is doing. I have seen students have really weird Eclipse experiences. They have an image and Eclipse swears the image isn't there, or they have Eclipse save a file and then they have, not Eclipse per se, but you're writing all your Java code in the Eclipse IDE. And they write the Java code to write to a file, and then they read from the file, and Eclipse says, I don't have any file like that. Well, you know it's a lie because it just did it. So it's something about how Eclipse is managing the pointers to the file locations. It can be difficult. I've also had situations where students were editing a Java file in Eclipse, and then they would save it and they'd run it, and the behavior wouldn't change. And then we'd do really drastic things like, let's put a big print statement here, and the behavior wouldn't change. Well, it turned out there were two versions of that file, and they were editing one and running the other. It's Eclipse. All systems like that are great because they help you. And they take the burden away from you of keeping track of the details. And then the bad news is sometimes you need the details to figure out what the heck is going on. So just be aware that that's a possibility. All right, so anyway, it couldn't find the file. And that's because I don't have the file. So let me instead do the write data, which will create the file. Now here's what happens. This thing says, hey, I want a new file called scores.txt. Again, what you're really creating in this case is the object that manages that file. But when you create it this way, it literally will create a new scores.txt file. Yes, there are a million variations. You may create a new file manager that opens existing files, as is what happens here. Okay, so if I run write data before I run read data, Java, write data, it looks like nothing happened, which is usually a good sign. But really what happened was, hey, now we have a scores.txt file. So there it is, scores.txt. And it's composed, its contents looks exactly like we thought it would. Let me manage my windows a little better here. There we go. It printed out John T. Smith 10 and Eric K. Jones 57. Why is the 10 on the same line as John T. Smith? Because they used print here. Print just keeps everything on the same line. And then print ln, remember, is how you get a new line. It does the line feed at the end. Could they have done it? Let's try this. Let's do this. If we try that. Let's see what happens. By the way, first I'm going to read the data. I read the data. Ta-da! I read the data. And then I'm going to lose track of what window I'm in. Then I'm going to compile. And then if I do write data again, and I look at the file. Oh, I didn't do print line. That's why. No. Print line. There we go. Try that again. Sorry, guys. Compile. Write. Open up the scores.txt. There we are. So notice when you were writing, even though in their example, they chose to, this is what I say, you know, when I say change it, break it, fix it, they chose to output that integer value 10 separately. They didn't have to because everything that gets pushed out is treated as a string. So they didn't have to do that. And then when you read in the values, let's see if this works out here. I'll be shocked if it doesn't work. Ta-da, it works. That normally how you create data files, though, is separate from the program that's reading them in and running them. So, for example, some of you guys are doing games where you have different levels, and my recommendation has been, hey, you might want to put your level information in a file external to the code. That way you can keep changing the levels without having to mess with your code, right? You again, try to separate the functionality of these things. You keep changing your files to change the levels, you don't have to keep recompiling your code every time you want to change a level. So normally, you actually can just put in data. I don't know why I care if it's capital. So I can save this thing, and then when I do read data, they're all there. So often you're going to edit your files. If you're doing a true data file, right, where you're setting up some kind of a level for a game, often the file actually gets created manually external from your software, and then you have to read it in. But again, plan ahead so that you know, right here I've got string, 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 int, and every line should be string, 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 int. By the way, let's play around with that. Let's move Eric to there and see if it matters. I don't know if it'll matter. I think this should work. Yeah, that works fine. What if I put Eric in twice? Will that work? No. Now, why did that not work? Because it's string, 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 int. So after John T. Smith, 10, that worked out fine. I get string, 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 and then we try to bring in the word Jones as an int. And there's no way you can convert Jones to an int. So that's where you get the failure. And what is it? It's an input mismatch exception. You told me you were going to give me an integer and you gave me a string. So you have to be careful, again, that your data files match what you think they should. Okay, now let's do one more thing. I want to make sure I fixed it. Yeah, I fixed it. Okay. By the way, what if I put a number in there? Doesn't matter. It treats the number as a string because it always comes in as a string. You know, one of the things that can be a problem sometimes, not so much in Java, but in other languages, is you're looking at the number 50 and you're trying to add 50 to something or multiply to 50 by something and you get a problem. And it's because you are looking at the number 50, the computer is looking at the string 50. Completely different animal. So Penny's middle name is 50. Computer doesn't care. All right, let me show one more thing. I'm going to write the data again. There it is. I write the data, and when I look at the file scores.txt, oh no, we're only back to Eric and John. What happened? Well, if you are writing to a file and you don't do anything special about it, you obliterate all the old data and start over. So this did not append to the old file. It just said, okay, new file. How do you fix that? There's a couple ways. One is you can read in all the old data, and then you can do all the modifications that you want to that data, and then ship it all out. And technically what will happen is, you know, the program will overwrite all the old file, but what you're doing is you've managed that situation. You're keeping your old data and adding your new data. You can also do more sophisticated file management operations where you're opening up to append and opening up to do cuts in the middle and things like that. Cuts in the middle are a little tougher. So just be aware that those are possibilities that you probably don't need to get into for this course. My recommendation for most of you, because you're going to do fairly simplistic file I/O, is open the file, bring it all in, change what you need to change, and then push it out. By the way, I recommend that when you do that, you don't like do a line and push it out, and then you do some more manipulations and push out the next line. Wait till you're ready to do the whole file at once. That's my recommendation. That way you're making sure that you've got a properly consistent set of data the way you intended it. Okay, only two more examples here. This one is the test file class. And what is this? We're doing, oh, hey, we're doing the image us.gif. So if I do this test file class, I like it. I like this example because it's giving you some nice examples of the kinds of things you can ask about a file. Remember what I said, this thing that we're calling file is not technically the physical file on the hard drive or in memory. It's really an object that manages it. But if you think about what an object does, again, what does it do? It allows you to perform actions, and it also can describe itself to you, right? It manages the state. So you can ask questions of this thing, right? Oh, that's kind of what an object should be able to do, is describe itself to you. So you can ask, you know, does the file exist? How big is it? Can I read it? Can I write to it? That kind of thing. Well, that's an awful good thing to ask. Maybe before you try to read from the file, you should make sure that its settings have been set so that you can read from it. And then we get these questions here. Does it exist? True. Notice, by the way, this was in the subdirectory image.us/us.gif. Does it exist? Yes. How big is it? It's only 3,000 bytes. Can it be read? Can it be written? Is it a directory? By the way, I've had students that build systems where they go up and down directories. Hey, if this is a directory, go into it because I'm looking for something. If it's not a directory, move on by. Is it a file? Yes. Is it absolute? False. I have to check what that absolute is. And then the absolute path. Now remember, what's the difference between the relative and the absolute path? The relative path is what we have here. It's relative to where I am now. Hey, wherever you're running this class file, in that same folder should be a folder called image. And inside that image is this us.gif. That's all location that's specified relative to where you are right now. But the absolute path is starting at the C drive. Give me all the folders that I need to get there. When you are using your file I/O, I highly recommend you use the relative, not the absolute. If you use the absolute and you move your code to somebody else's computer, almost certainly the absolute path won't be correct, and then your code won't work. But sometimes it's useful to know the absolute. So there it is, C CS225, module 09, file IO, image, USGIF. And it's an old file, been around since 2014. So I like this example just because it gives you some idea of some things that you can do. You can also, by the way, since it says, can it be read? And the answer is true. And can it be written? The answer is true. That should give you a hint. You can lock those files, right? You can set the can I write to it toggle to false, and then people can't overwrite that file by accident, or more likely you won't overwrite that file by accident. And then the last example is this replace text. And the reason I like this one, number one, it does show you, you bring in a file and modify it and put it back out. But it also finally, we get to use the arguments in the, public static void main string args. And we've never used string args yet. And this one actually uses string args. So if I say, Java replace text, and it's going to say, hey, you didn't do it right. And it tells me, here's what you're supposed to do. Here's the usage. Java replace text. And then I need 4 things after that: source file, target file, old string, new string. And what are we looking at here? We're looking at setting up the input parameters to the replace text class. So public static void main string args. What is string args again? It was an array of strings. And that's what I'm giving it, an array of strings. And so if we look here, public static void main string args, and then, the name of that is args. And so they check, hey, I needed 4 parameters: old file, new file, old string, new string. So check to make sure the user gave me 4 parameters. If they didn't, then tell them how to fix the problem. Whenever you give an error message, tell the user how to fix the problem. And then quit. Then they check other stuff. Make sure the source file exists. If it does not exist, quit. Make sure the new file exists. Now here, what they're doing is they want to make sure not to overwrite an existing file. So if the new file already exists, then say, hey, this thing already exists. Basically, it's, are you sure? You've done this before, where you try to save a file that has the same name as another one, and the system says, are you sure you want to do that? Right. So, and then quit. But once we get through that, where we're checking that everything was right and the source file exists, and then scan our input from the source file, print writer prints to the target file. Whoops, I need to be careful here. And all they do is they input the entire line. Now they're bringing the entire line in at a time, and they're treating it like a string. And then they're going to create a new string where they replace the old text with the new text, and then print out the new string. Pretty straightforward, really. I mean, you can do some file manipulation with just a few lines of code if you need to. Let's run this thing. Let me see. What do I have here? Do I have a scores.txt? Let's put in now notice, by the way, it doesn't matter what it doesn't matter about the formatting with the numbers at the end, because this is going to bring in a line at a time. And let's take all these, I don't know, how about capital C, and replace capital C with a number. So if I say Java replace text, scores.txt is my source file, and I'm going to say new scores.txt is my new file, and I'm going to replace capital C with the number 35. That should show up pretty bright. And won't do it here because I haven't, but if I look at the scores.txt, new scores.txt, there it is. Capital C's were replaced with 35. We could have done, let me delete this thing. Replace Mr. Smith with Mr. Jones. And now Eric K. John T. Smith is now John T. Jones. So these 4 examples pretty much get you on your way to do what you need to do in the course. The write data and the read data tell you how to write to a file and read to a file. The replace text gives you a nice example of bringing in the file and then outputting. Had I done this, I wouldn't have, well, since you're printing out to a new file, I probably wouldn't have printed out line by line if I had made this myself. I probably would have made one big long string and then printed it out that way. That's just me. Another example that they give you is you can actually go right to the web and read from a URL, and then you can do analysis on web pages. Java, one of the goals of Java when they designed it was to be highly portable, really easy to be networked so that you can build some code on your machine and some code on a friend's machine and have them connect together and, you know, play games or whatever you're going to do, run multi-threaded programs, that kind of thing. That was the goal of Java, and they did a really good job of it. So it is pretty easy to actually go out to the web and get pages and display them if you want to, or do analysis on the text if you want to, that kind of thing. It's not that difficult. And that's that. Do we have questions? Concerns? All right, then I am going to let you guys go. Have a great day. And we'll meet Friday talking about the project.